Your first step is to set up a 400 milliliter beaker to act as a water bath for your 125 milliliter flask. Secure the flask inside the 400 milliliter beaker with a test tube clamp and tightly tighten it down to the stir station. Fill the 400 milliliter beaker just about to the neck of the flask with water and add a stir bar to the inside of the 125 milliliter beaker. Even though the stir bar is well above the magnetic stirring base, the bar will still move inside the flask. Make note where you have set your stir station setting. It needs to remain constant on all trials in the lab. Plug a stainless steel temperature probe and a gas pressure sensor into two of the channels in the top of your LabQuest. It doesn't make any difference which two channels you plug into. Turn on your LabQuest by holding down on the power button on the top left corner of the LabQuest. It'll take a couple of seconds for the LabQuest to turn on. The LabQuest should automatically display the temperature and the pressure readings coming from the sensors. Make sure that the temperature reading is somewhere between 20 and about 24 degrees Celsius, and that the pressure reading is in the neighborhood of 100 kilopascals. That way you know that everything is working properly. Set up the LabQuest to collect a new round of data by tapping the File menu and pulling down to New. Now we want to set the mode in which we're going to collect our data. We could do this with our manual start and stop buttons, but we're going to make it easier by setting the length of time and the number of samples so that the LabQuest will do most of the work for us. First of all, tap the Mode menu in the upper right-hand corner. This brings up a time-based screen where we can set the length of time and the number of samples that we want to collect. The LabQuest is automatically set up to collect data for 900 seconds, which is 15 minutes, which is a bit too long for us. So instead, we're going to click the Length button and change the length of time from 900 seconds to 300 seconds, which will be 5 minutes. It should be just about right. So merely click the box and a small keyboard will pop up on the screen and you can just enter the length of time you want, in this case 300 seconds. The next thing we want to change is from 1 second per sample, we want to change that to 10 seconds between samples. It'll reduce the amount of data points and not make our data so cluttered. So again, just touch the box and enter 10 seconds between samples. Now click OK. Now you can measure out the reactants that you need for trial 1. You'll need 45 milliliters of distilled water, 5 milliliters of half molar potassium iodide, and 10 milliliters of 3% peroxide. I like putting these in 3 different size graduated cylinders so it's very easy to keep track which reagent that you're dealing with. Add your 45 milliliters of distilled water and your 5 milliliters of potassium iodide to the reaction flask. Reserve the peroxide for last. After adding your hydrogen peroxide, quickly attach the rubber stopper connected to the gas pressure sensor to the top of the flask, making sure that it is airtight. Place the stainless steel temperature probe in the water bath and adjust the stir rate on the magnetic stirrer to the predetermined setting. Click the Start button on the lower left-hand corner of the screen, and you should see data start being collected immediately. You could stop this trial at any time by punching the red square Off button, but the LabQuest will do all the work for you. Just sit back and wait 5 minutes. You should notice some oxygen being produced in the reaction chamber, and the potassium iodide will start showing a characteristic yellow color. Remember, this should run for 5 minutes and should stop automatically. At the end of the trial, the LabQuest will automatically bring up the graphs of the temperature and the pressure, showing your results for the entire trial. Analyzing your data in a LabQuest is incredibly easy, which is one reason that it's such a great lab tool. First of all, we're going to figure out what the average temperature was over the 5-minute trial. And to do that, we're going to touch the Analyze button at the top of the graph menu and pull that down until we reach the Statistics and move your stylus to the left and choose temperature. That way you're choosing to view the statistics for just the temperature probe. When the graph pops back up, you'll notice that in the temperature setting it says 23.0 degrees Celsius, and that's our average temperature over the run of the trial. Now we want to analyze the pressure data. To do this, we want to select a portion of the pressure graph where it looks as if the data is increasing fairly rapidly and at somewhat of a linear rate. To do this, take your stylus and touch a portion of the graph where you wish to begin your selection and simply drag it across about a 30-second segment until you reach the other end. Once you do that, that portion of the graph will be selected, and now we can analyze it further. Now that we have our section of graph selected, what we want to do is to determine the slope of just this portion of the graph, because remember, what we're looking at in this lab is that we're looking at the rate that the oxygen was being produced, and the way we're going to analyze that is by the rate that the pressure was increasing. So again, we're going to go up to the Analyze menu, and this time we're going to pull down until we reach Curve Fit, because what we want to know is the slope of that line. Pull your stylus to the left and select the pressure sensor. Now the LabQuest is going to ask you what kind of mathematical operation you want to try to analyze this graph with. Well, you want to know what the slope is, so you're going to tell the LabQuest to choose the fit that is linear for this choice. So under Choose Fit, pick Linear. And as soon as you release the stylus, the LabQuest is going to analyze the data and tell you what the slope is. Once you leave the Curve Fit screen, the LabQuest will still remember that you were after what the linear value was for the slope of that line, and you can pull it back up on the right-hand side of that menu. Remember, the slope of this line is the rate that the pressure was changing per second for the oxygen. So it is the rate that the oxygen was being produced in the unit of kilopascals per second. You're going to use the same method of data collection for your other trials using various amounts and concentrations of reactants. So what you need to do is dump out your reaction chamber, rinse it with water, dry it as best you can, and then we're going to repeat the process with your other trials. Another nice thing about a LabQuest is that it assumes that between different trials, which the LabQuest calls runs, that you will want to use the same setting for each trial. So to start your next trial and all subsequent trials, all you have to do is hit the green Start button on the lower left-hand corner. Good luck with your lab.